Picture a pond in the tropical north of Australia, on an afternoon hot enough to bend the air above the mud. A scientist is crouched at the water's edge, and she has been there for hours watching thousands of baby toads no bigger than a fingernail gather in the shallows, getting ready to crawl out of the water and begin their lives on land. Here is what every animal on this continent had learned to do about those baby toads. Nothing. Leave them completely alone. For almost 100 years, anything that touched one of these creatures died for it. And that lesson had been burned so deep into the instincts of every predator in the country that the toadlets sat on that bank in perfect safety. The one thing on the entire shoreline that nothing would dare go near. That is the world she expected to be watching, except something is moving toward them. A dark column pouring up out of the soil, thousands strong, heading straight for the toadlets. Not around them, not past them, straight in. And she can see at once that this is not a swarm defending its home. This is a hunt. For almost 100 years, this toad has been the most destructive invader on the continent. A walking chemical weapon that kills crocodiles and snakes and giant lizards with a single bite. Everything ever thrown at it has failed. Fences failed, traps failed, tens of millions of dollars failed, and now something on this muddy bank is quietly taking it apart. So what is moving across that ground, and why, after 90 years of dead predators, is the toad's poison doing nothing at all to stop it? Stay with me, because once you see what these animals do, and once you understand why it works, you cannot unsee it. To understand how one animal did this to an entire continent, you have to go back to a single decision made with good intentions that could never be taken back. Australia spent tens of millions of years cut off from the rest of the world, and in that long isolation, it built a web of predators and prey so finely balanced that one wrong piece dropped into it could pull the whole thing loose. In 1935, someone dropped that piece. Sugarcane farmers in Queensland had a beetle problem. The grubs were chewing through the crop, and the fix on the table looked clean and obvious. Import a heavy South American toad already known to eat beetles elsewhere. Turn it loose in the cane fields. Let nature manage nature. A little over 100 of them came in through Hawaii and were released into the tropical north. Nobody thought twice. For a few years it even looked smart. Toads like these had been shipped around the world's cane-growing regions before, sold as living pest control, and no one had raised an alarm. They bred on their own and cost almost nothing to keep. The men who let them go were not villains. They were trying to save a harvest with the best information anyone had. The disaster they set in motion would still be growing nearly a century later, long after every one of them was gone, and the toads never touched the beetles. The grubs lived high on the cane stalks. The toads were ground-bound animals that could barely haul themselves off the dirt, so they ate everything else instead. Native frogs, native lizards, small mammals, the insects that actually did some good. Then they bred harder and faster than anything the country had ever produced, dropping eggs into every dam and ditch and tire track full of rain they could find. Nothing here could slow them down. No predator that could survive biting one. No parasite adapted to them. No native competitor that could crowd them out. For an animal built like that, an entire continent is an open buffet with no bill at the end. Those first 100-odd toads became more than 200 million. The front pushed west and then south at close to 40 kilometers a year, rolling out of Queensland into the Northern Territory, across into Western Australia, down toward New South Wales. And by the time anyone understood the true size of the mistake, there was no calling it back. You cannot recall 200 million animals scattered across an area bigger than most countries. All Australia could do was watch it come and count what it killed. Here is the mechanism, and it is the whole tragedy folded into a single moment. A cane toad carries two large glands behind its head. They hold a thick, milky poison strong enough to stop a mammal's heart in minutes. A native hunter sees a slow, round, easy-looking meal sitting out in the open It bites down the way it has bitten down for 10,000 years, and it is dead before it understands that anything has gone wrong. That poison is not a choice the toad makes. It leaks out through the skin the instant anything clamps down, and the glands hold enough to drop an animal many times the toad's size. A dog that mouths one in a backyard can be convulsing within minutes. A meter-long lizard that has hunted snakes its whole life has no more defense against it than a house pet. The toxin does not care how big or experienced the hunter is, it only needs something to bite. And that is the cruel design of it. The way most Australian predators kill is to clamp and crush. Clamping is exactly the motion that floods their mouths with poison. The harder they fight, the faster they die. Researchers could track the die-offs moving across the map year by year, following the toad front like a shadow that switched off whatever it fell across. In some regions, native predator populations crashed by more than 90% in the years right after the toads arrived. The pattern repeated with grim reliability. The toads would show up, the big predators would die first, and within a couple of seasons, the surveys that used to record goannas and quolls and crocodiles came back nearly empty. Northern quolls, spotted marsupials the size of a house cat, were almost wiped from ranges they had held since long before people arrived. Yellow-spotted monitors, the big lizards that patrolled the northern riverbanks, vanished from country they had walked for thousands of years. Freshwater crocodiles took losses that should not have been survivable, and when the animals at the top go, everything under them comes apart. Feral cats and foxes poured into the gap, and half a continent's food web pulled loose at the joints at once. The toads never had to fight a thing. They only had to sit there looking edible and let the continent's own instincts do the killing. An invader that wins by being eaten is a strange and terrible kind of weapon, which is why what Georgia Wardfear saw at that pond mattered so much more than its size. Wardfear is a biologist at Macquarie University. The research she runs alongside Rick Shine, who has tracked this invasion across the country for decades, keeps them down at ground level for hours at a time, watching thousands of those fingernail-sized toadlets get ready to leave the water. On the blistering afternoon everything changed. She was watching that same bank, expecting the same nothing that always happened there. Then the column came out of the soil, meat ants, thousands of them, moving straight at the toadlets. And she could see at once that they were not defending a nest, they were hunting. So she did the only thing a scientist can do in a moment like that. She kept watching and she got it on camera. Because without footage, no one was going to believe a word of it. What the lens caught was not a fluke. It was methodical, it was repeatable. It was the kind of thing that, once you have actually seen it, you cannot unsee. And it is worth being clear how far this went against everything the experts knew. The textbook said the cane toad had no effective native predator at its vulnerable stage. Decades of watching predators die had settled the matter. Nothing native could take these animals on and come out ahead. What Wardfear was filming did not add a footnote to that picture. It kicked a leg out from under it. What stopped her cold was the coordination. The ants did not bite once and pull back to test the danger, the way almost everything else on the continent had learned to. They locked onto a single toadlet from every angle at once, pulling in opposite directions, taking it apart while it was still alive. The baby toad's chest was still moving. The white poison was visibly active on its skin in the afternoon light, and the ants did not stop. They did not even slow down. For 100 years, that poison had been the final word in every confrontation on this continent. Bite the toad, taste the toxin, release or die. Every predator eventually learned the rule or was removed for breaking it. The ants pouring across that bank were not reading the rule at all, which left exactly one question that mattered. How does an animal you could lose under your fingernail beat the most poisonous creature on the continent? When a meat ant bites a baby toad, the toad does the one thing its body was built to do. It freezes, it holds perfectly still, pushes poison out through its skin, and waits for the attacker to collapse. For almost 100 years, that has been a flawless answer. A snake bites, tastes the toxin, lets go, or dies. The toad's entire defense is built around that single response, and against nearly every predator this continent has, it works. But the ants are immune. Their bodies simply do not contain the machinery the poison was built to attack. So while the toad holds itself rigid and waits for a collapse that is never coming, the ants keep working leg by leg until there is nothing left to defend. The smaller animal wins every time. Think about what that means. The toad's whole evolutionary inheritance, millions of years of chemistry refined into one of the most effective poisons in the animal kingdom, is aimed at a target the ant does not possess. It is like firing a heat-seeking missile at something that gives off no heat. The weapon is real. It launches and it sails straight through into empty air, while the thing it was meant to stop keeps walking. And it helps to understand what a meat ant colony actually is, because these are not fragile insects. They build sprawling gravel-topped nests that run for meters underground and hold tens of thousands of workers. And they are known across the north for swarming anything that disturbs them within seconds. They had been living beside the toad invasion the whole time, sharing the same heat and the same water. The only thing that had changed was that someone was finally watching closely enough to see what they did with it. Then Ward, Fear and Shine's team put a number on it, and that is when the rest of the field sat up. In some monitored areas, the meat ants were killing up to 98% of the baby toads coming out of the water. 98%. That is not a curiosity buried in a journal. That is the kind of figure that can turn an entire invasion around. At ground level, they watched the whole thing run. Ants seizing toadlets by a single leg and dragging them, still moving, back toward the nest. Scouts reaching the colony the instant contact was made, reinforcements arriving within seconds. Not frantic, organized, almost industrial. A colony handling a poisonous animal the way it would handle any other protein that wandered too close. But the killing only works inside one narrow slice of time, and that window is the whole game. The toadlets are only this exposed for a brief stretch right after they finish the change from tadpole to tiny land animal, a phase scientists call the metamorph stage. At that age, they are slow, clumsy, and forced out into the open because they cannot yet control their own body temperature. They have to sit in the sun to warm up. They have no choice, and they emerge all at once. A pond boiling with tadpoles will push thousands of metamorphs onto the bank over a day or two in one synchronized pulse. It is a survival strategy older than the species. Flood the zone, overwhelm whatever is waiting, let sheer numbers carry a few survivors through. Against most predators, it works. Against a standing colony of ants already stationed on that bank, it simply means thousands of targets arriving at the worst possible moment. And the same heat that drives the toadlets into the open kicks the meat ants into their most aggressive high-energy hunting. The ants are fastest at the exact moment the toadlets are slowest. The two rhythms line up so cleanly it almost looks arranged, as though the continent set a trap and waited for the invader to step in. Here is the part that is genuinely hard to watch. The toadlets have time to react. A native frog that size would have jumped. A native lizard would have melted into the grass. The baby cane toads do neither. They sit there. Their entire survival manual was written on another continent in South America for predators that spent millions of years learning to respect toad poison. Over there, holding still and poisoning your attacker is the right answer. Here, against an enemy their biology has never met, that same instinct is a death sentence played out in slow motion, which left the team with one obvious problem. If the ants are already doing this for free, how do you get them to every pond at once? And this is where it stops being science and becomes almost absurdly simple. The toads were spreading into places where the ant colonies near the water were not yet thick enough. The ants were winning every fight they were in, they just were not in enough places. So someone asked the question no one had thought to ask. What if you bring the ants to the pond? The answer was sitting on a shelf in every supermarket in the country. Cheap, fish-based cat food, the kind you can smell across a room on a hot day. You open the cans, set them along the muddy edge where the toadlets are about to emerge, and wait. That is the entire plan. After tens of millions of dollars spent on fences, trapping, laboratory work, and gene editing proposals, the most promising weapon in 90 years cost about as much as a sandwich. And it works almost at once. Within minutes of the cans going down, the ground begins to move. Meat ants pour in from every direction, set up a perimeter along the water's edge, and hold it. When the toadlets crawl out, they do not find a quiet bank to start their lives on. They find a living wall of immune killers already waiting for them. In baited zones, the density of ants rose more than fourfold, and predation on the emerging babies went nearly vertical. There is a second trap hidden inside the first. The bait does not only pull the ants in, it pins them in place. A tin of strong-smelling protein keeps workers parked in one spot for hours, right across the window when the toadlets are coming out. And because cane toads take in water through their skin instead of drinking it, a few extra hops from the pond in that heat starts drying them out within hours. So even the toadlets that slip past the ants are not safe. Pushed back from the only moisture for hundreds of meters, a fingernail-sized amphibian has very little time before it dries out. Ants, heat and thirst, stacking against one tiny animal at the moment it can handle none of them. No fence ever managed that. No trap ever came close. And the cost is the part that stings. Set a few tins of cat food against the tens of millions poured into fencing and trapping and laboratory work across the decades, and the comparison stops being ironic and turns uncomfortable. The expensive tools were designed by specialists, defended in papers, funded for years. The thing that actually moved the numbers came out of a pull-tab can. It spread the way genuinely useful things spread. Quietly, person to person, with no press release. Wildlife rangers tested it around fragile habitats. Landcare groups in the Northern Territory set cans near ponds where endangered quolls were hanging on by a thread. Farmers tried it along the edges of their dams. Nobody needed a permit or a grant or a committee. They needed a few dollars and an afternoon. But there is a hard limit on all of it, and it is the reason this is a long game and not a quick win. A full-grown cane toad is a completely different animal. It can weigh several pounds. Its skin is thick and hardened. Its poison reserves enormous. It moves through an ant nest the way a person walks through light rain. The ants are not killing the adults. There is no fight to have. The ants are cutting the pipeline, and the pipeline is everything. A single female cane toad lays between 8,000 and 30,000 eggs in one cycle. But take almost all of them out at the metamorph stage at the water's edge before they ever grow big enough to be untouchable, and the arithmetic flips. The adults age out and die. The replacements never arrive. A front that once moved 40 kilometers a year begins, in places, to stall. And the ponds are where you do it, because the toads cannot go around them. Every cane toad on the continent has to pass through water to exist. The eggs go in the water. The tadpoles grow in the water. And every last one has to cross that same narrow band of mud to reach land. It is the one point in the whole life cycle where the entire population is funneled into a thin, predictable strip. Slow, soft, and fully exposed. Control the edge of the water, and you control the only door the species has. Take 90-odd% of them, year after year, at the same choke point, and you are not just slowing the invasion, you are bleeding it. Because the strangest part of all is what the toads have started doing in response. They are evolving fast enough to watch. The toads at the leading edge of the invasion have grown measurably longer legs. They cover more ground in a single night. Their bodies are leaner. Even the shape of their hips has shifted to carry faster, longer travel. The bold ones push out to the front, the cautious ones fall behind and never breed with the runners at the tip. Generation after generation, the fastest breed with the fastest, and the point of the invasion gets sharper every year. This is what genuinely unsettles the people studying it. We tend to think of evolution as slow, something that happened to other animals in other ages and gets rid of old bones long after the fact. This is happening inside a single human career. The scientists who watched the toads arrive are now measuring their leg bones getting longer season by season. Two species locked together, both changing in real time with a camera running. And the ants are not the only ones adapting. All across the north, native animals are quietly working out how to beat a poison that was supposed to be unbeatable. Some crows flip cane toads onto their backs and eat them from the underside, where the glands cannot discharge. Water rats in the Kimberley cut out the toxic organs with near surgical precision and eat the rest, leaving piles of tissue so cleanly stripped that researchers first assumed a person had done it. Certain ibis wash toads over and over before swallowing them, diluting the poison enough to survive the meal. Freshwater snakes drag baby toads under the surface, where the glands cannot fire at full strength. Even large burrowing spiders at the pond edge have been filmed pulling young toads down into their tunnels. None of this was happening 20 years ago, and none of these animals are being taught. Nobody is showing the crows how to flip a toad or the water rats how to dissect one. The continent is running a brutal, unsupervised experiment with millions of trials at once. The knowledge is never taught. It is selected generation after generation, until a trick that started as one lucky accident becomes simply how the locals handle toads. And you can understand why so many people did not want to believe the ants. The ecologists who first heard the claim had given decades to this fight. They built the fences, ran the trapping, wrote the proposals. To be told that the thing finally moving the numbers was a colony of ants and a tin of supermarket cat food was almost too much to take. It sounded less like a breakthrough and more like a joke at their expense. Many senior ecologists flatly rejected it at first. The numbers looked too clean, and then the data held. Study after study, the ants kept doing exactly what they were doing, and the lesson settled in. Sometimes the answer to an enormous problem is not an enormous intervention. Sometimes it is noticing the small thing that has been quietly working on its own for free and giving it room to run. None of this has undone the disaster. The toads are still here. They are still pushing west. They are still poisoning anything naive enough to bite them. But the ground beneath them is shifting in a way it never has before. And whether that shift is enough to save the last untouched corners of the country will not be settled in a headline. It will play out over the next 2 or 3 decades, pond by pond, season by season, while the toads keep evolving and the natives keep learning. That is the honest place this story ends, not with a solution, not with a defeat. With a bank full of tiny, poisonous animals, a colony of ants that never asked to be recruited, and a continent that is still deciding, one pond at a time, whether it can hold the line. So here is what I want to leave you with. Do you think an army of ants, baited into position with cat food, can actually turn back a species that lays 30,000 eggs at a time? Or is that simply too much math for anything alive to beat? Tell me in the comments. I read them, and the sharpest predictions almost always come from you. And if the most effective answer to a 90-year disaster really has been sitting in the pet food aisle this whole time, it is worth asking what else we are all walking straight past. If this is the kind of story you want more of, subscribe and tap the bell so you are here when the next one refuses to stay buried.